Happy Monday, everybody. So I want to keep talking about this idea of a significance test and how this all works. We're pretty much going to do the same thing this unit that we did in Unit 7. If you remember, I introduced what the concept was of a confidence interval. Then I showed you how to calculate a confidence interval for a proportion. Then I showed you how to calculate a confidence interval for a mean. We're basically going to do the same thing in this unit. So now we're looking at, okay, we have this sample data. We have this statistic that's already assumed to be true that's out there. How can we test it using our sample data for a proportion? And how can we test it using a mean? So today we're going to start with the proportion aspect of that. So there's a lot of information on the screen, but the main important part is that there's conditions, just like there were for confidence intervals. So what we have to do is we have to check our conditions before we can move forward with a significance test. So the first one is the data random? And that's as simple as long as they use the word random in the question, yay, check mark, you're good. So it's pretty easy. And then large counts, just like it was for proportions for confidence intervals. Make sure that NP is greater than or equal to 10 and that N times 1 minus P is greater than or equal to 10. Here's the part that might screw you up a little bit though, okay, that I want to clarify. When we were doing confidence intervals, okay, we were using our sample data to estimate what true P was. So all we had was P hat. So when we were doing our conditions, we were using P hat because that's all we had to work with, right? Well, now that we're looking at significance tests, we are given the true P, right? Like that's the statistic we're trying to disprove essentially. So in that case, you are using actual P for both of your conditions. So that's kind of weird, kind of confusing. The main way is, that I kind of think of it is if you have the real P to use it for your conditions. If you don't have the real P to use, then use P hat because that's all you have to work with. Okay, so that's kind of weird, but I think you guys can handle it. You'll be okay. All right, so here's an example. The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food after placing an order. Based on store records, the proportion of customers who had to wait longer than 2 minutes was 0.63. To reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. The manager would like to carry out the test at a significance level of 0.10. So here's what's happening, right? So far, this is what, oh, I didn't mean to have my pen, sorry. I meant to have my highlighter. So far, this is what's going on. About 63% of the time, the customers had to wait longer than 2 minutes. So the manager's saying, all right, I'm gonna get another employee and I'm gonna see if we can kind of reduce that. So now he's thinking, now that he has this new additional employee, all right, he's thinking that, all right, it's gonna be less than 63% now that are having to wait that long, okay? So during the next month, manager collects data on wait times from a random sample, so yay, conditions, and finds that only 141 of the 250 had to wait longer than 2 minutes. Check the conditions. So all we would do is we'd say, okay, yep, he said a random sample of 250. We're good there, okay? And then for large counts, notice how we're using the actual p-value because we have it, okay? We're not using p hat. We're not using the 141 out of 250, okay? If we did 141 divided by 250, I'm doing that right now, we'd get 0.56 as our p hat, okay? So notice, all right, so our p hat is 0.56. So notice right here, our p hat is 0.56, but notice how they're using the actual p-value when you go to calculate the conditions. So that's what I'm talking about. If you have the actual p-value, use that in your conditions. If you don't, that's when you use p hat. So for confidence intervals, for example. All right, so here you can see they calculate the p hat again, okay? Now here's the deal, because this result is less than 0.63, there's some evidence against that. Like there's some evidence saying like, hey, by hiring this extra employee, you're actually doing better, less of your customers are waiting. But the big thing is, do we have convincing evidence? That's the huge concept of this. Do we have enough from this one tiny sample of 250 people or 250 customers to say, oh, yep, I'm good. I'm going to keep this employee. It's worth it. Okay. So that's where the p-value, the alpha level that we pick, all of that, that's where all that comes in, and that's where we're going next. How do we know it's convincing evidence, not just, oh, I took one sample. Yep, I'm going to disprove everything I've thought so far. All right, so a couple things to remember, okay? If you want to find the mean of the data, you're just using that p-value that's already established, right? Like that's already been proven that 63% of this guy's fast food customers wait longer than 2 minutes, okay? Then you're also going to use that same p-value and notice how he uses the sample number to get the standard deviation. So basically what we're looking at is assuming that both those things are true, because that's what we're doing right now. We're saying those things have already been established. I'm going to make this normal curve, and I'm going to say, okay, though, but here's my sample. This is where it lands in that normal curve. And so to be able to figure out that number in comparison to everything else, we change it into a z-score. So we do p hat, right? So z equals p hat minus the actual p that we're looking at, the mean, and the standard deviation. Okay, so it's just like when we found z-scores earlier in the school year, right? Data point minus the mean over the standard deviation. So you'll see that they use those numbers right here to get a z-score. So let's do an example practice problem. So here's a practice problem. Suppose you want to perform a test. Here's our null hypothesis. The alternative, we think that the proportion's larger than 30%. And there was a simple random sample of size 50 that yielded 19 successes, okay? So first thing we figure out is what's our p hat, okay? So we do 19 out of 50 and we get that our sample proportion is 38%. So again, this has some convincing evidence that, hey, it's bigger than 30%. I'm feeling good. But how do we know it's convincing enough? How do we know it's enough to completely disprove the null? So what we have to do is change it into a z-score. So here's our data point, the 0.38. Here's the established number that we're looking at. And I know it's not mean technically, right? It's proportion. So it's kind of like our data point minus the established data point all divided by the standard deviation, and you get a z-score. So I think you guys can see where we're going next. Eventually, we're going to take that z-score and we're going to actually calculate our p-value, which is what we were talking about last week. So that p-value will help us figure out, yes, it's convincing evidence. We've totally disproven the proportion is not 30%, or, well, technically this could have just happened by chance and we need to try again. So here's just a picture of how this works, right? So here's that p hat from before for the fast food restaurant. So now we've just changed it into a z-score. And the whole idea is we're going to use that z-score to find the probability that we got that p hat or smaller, right? Because we were looking at our alternative was we think that it's less than that 63%. So that's why we're going to the left of that z-score. What's the probability we got that data point of 56% or less purely by chance, okay? My recommendation, use normal CDF, okay? Say, all right, normal CDF, and then type in the -1000, comma, -2.13, comma, the mean, which is 0, comma, the standard deviation, which is 1, okay? You can technically do that over here as well without changing it to a z-score, but the reason I want you to change it to a z-score is some of you guys like using the table better, and so this way you can use the table as well. But also when I go to teach you significance tests for means, that's going to come into play. So I don't want you to skip too many steps and then have that kind of catch up to you later, okay? So here's an example of that. So refer to that previous example where the standard test statistic was a z-score of 1.23. Assume the conditions for carrying out the test are met, find that p-value, okay? So what we were looking at before is we think the proportion is bigger than that 30% is the one they're referring to, okay? So since we think the proportion's bigger, we're saying, all right, what's the probability we got that p hat, which we changed to a z-score? What's the probability we got that score or higher purely by chance? And so you're just using normal CDF, right? So using technology, your lower would be 1.23, comma 1000, comma 0, comma 1, okay? You can also use the table, right? So you can absolutely use the table to help you figure out that value as well. Notice how both numbers are pretty much the same, but remember we've talked about technically using your graphing calculator and using technology, you get a slightly more accurate value. So if you can, I would use a graphing calculator. Plus, I think it's a little faster personally. So a couple things I want to talk about really quick, okay? So we got that p-value of 0.1093 on that last page, okay? They didn't actually pick a significance level. So if there's not one stated, you can kind of assume it's 0.05. So because the p-value, right, is greater than the alpha value, we failed to reject the null. We don't have convincing evidence that the population proportion is greater than 0.3, okay? Here's the key word right there. We don't have convincing evidence. Do we have some evidence? Well, yeah, we got a number that is actually bigger than 30% when we tested it out. But it's not enough to say that we're totally scrapping what's the statistic that's already been established, okay? So something I want you to think about just as kind of an extension thought, remember, we cannot conclude that assigning an additional employee caused the decrease in the wait times. Like I kind of mentioned that earlier. I was like, oh, the extra employee, that's why they're waiting longer. There's so many other factors that could have led to that data. We can't say cause and effect in that way. It's kind of like if you think about your science classes, you just assume that this one thing changed it. When he hired that other employee, what if that other employee brought a lot of morale, right? What if the manager, because he knew that 63% was so high, he started changing other things in that fast food restaurant to try to make it less of a wait time, right? So just because we have evidence disproving something doesn't mean that it caused that to happen. All right, you guys. So homework number 2 was a little bit lengthy, so I decided to split it into 2 parts. So I want you to do part 1 today and submit that on Google Classroom. Tomorrow, I will show you guys one extra step to calculating these proportions and the p-values, things like that. And then you'll do part 2 of the homework assignment tomorrow, okay? Don't forget, if you have questions, stop by and see me for office hours so that I can help.